Alright, next example is example E. We have log base 8 of x to the third power equals 12. So this is properties of logs. I know we had a whole week break, but before that, whenever you had an exponent inside of a log, what did you do with it? Yep, you take it and you move it out front. So now we have 3 times log base 8 of x equals 12. So if we want to find out the value of x, we can tell we're going to need to write this as an exponent. But before you write it as an exponential, you have to isolate the log. Well, it's 3 times a log, so we need to divide it by 3. Alright, so now we have log base 8 of x equals 4. So we're going to write it as an exponential. The base of the log is 8, so the base of the exponential is 8. Over here, as a log, the x is with the 8. So then the 8 is going to be with the 4. The 4's turn to be with 8, and it's going to be equal to x. 8 to the 4th power, 8 times 8 times 8 times 8. So x equals 4,096, or 4,096. All right. F. 4 to the x equals 13. Okay, so this one we have an exponential, but we cannot do a common base because we cannot write 13 as a base 4 exponent. So when a common base is not possible, rewrite in log form. Okay, so we're just doing this one going the other direction as we did in the one above it. Here we had log turned into exponential. Here we have exponential, but the x is in the exponent and we cannot make these the same exponential base. So we're going to write this as a log base 4. The exponent is base 4. So log base 4 of 13 equals x. And that is the exact answer. Without a calculator that does a log function, we can't figure it out any more than that. That's exact. Because x is by itself. So we can say with a calculator, x is approximately 1.850. If you were asked for the approximate value of x. But without a calculator, we could only go log base 4 of 13 equals x. All right, so then example G, we're going to do an exponential base e. So e to the 4 minus 3x equals 6. And this one you could also just rewrite, but I'm going to show you another way. And this one is a pretty simple one where you could just rewrite it. But along with this note, sometimes it's more complicated and you can't just rewrite it. So, or take the log of both sides. and you choose the log base to match the exponent base of where your variable is. So in this case, I have an base e, and there's the x is with the e. So that tells me I want to use a log base e. So the natural log, so I'm going to do ln e to the 4 minus 3x equals the natural log of 6. So ln e to the 4 minus 3x equals ln 6. We have to do the same log on both sides. That's very important. You can't just do an ln over here and a log base 6 over here because, I mean, you just can't. Just like whenever we divide by 3 up here, we couldn't divide by 3 on this side and divide by 3 on something else over here. You have to do the same thing on both sides. Same whenever we're doing a log. We did ln because we wanted that base e, because the natural log is base e. So we have to do ln on the other side also. Then we have a log with an exponent inside. So we can take the exponent and move it to the front. And when we do that, we see we have the natural log of e. The natural log of e is just 1. So I have 4 minus 3x. I could write times 1, but who really wants to write out times 1? It's not very helpful. Equals ln 6. And if you remind yourself what it is you're trying to do, every once in a while we have to do that. What is it I'm even trying to do? Trying to get x by itself because I'm solving for x. So here's x. So that means I have 4 minus 3 times x. So that's a positive 4. I want to subtract 4. So I'm going to subtract 4 from the ln 6. When you do that, be very careful. You're not subtracting 4 from 6. You're subtracting 4 from the natural log of 6. So this is where having your argument in parentheses can be useful, because we're not going to have ln 2. That would be incorrect. We have 3x, or negative 3x, equals ln of 6 minus 4 on the outside. Then we're still trying to get x by itself, so we're going to divide by negative 3. So x equals ln of 6 minus 4 divided by negative 3. And that is the exact answer, which is approximately 0.736. And then the last example is a long one. I'm just showing you a lot of different situations you're going to run into. So we have 4 to the 3x minus 1 equals 3 to the 2 minus x. And this is why I showed you that last method, even though we could have done the last method by just rewriting. Because sometimes you can't just rewrite. And we can't make the exponentials the same base because one's a base 4 and one's a base 3. So in this case, we're going to use the common log. Use the common log to take the log of both sides. Okay, so if we take the log of both sides, so if you have an exponential, there's an x in the exponent on both sides. I can't match the bases. Kind of running out of things to do. Just use the common log and do log of 4 to the 3x minus 1 equals log of 3 to the 2 minus x. And then properties of logs tells me I can take the exponent and move it to the front for both of them. I can do it for the log 4, and I can do it for the log of 3 also. Move its exponent in front of it. So then I write the exponent. I'm going to put in parentheses 3x minus 1 log 4, log of 4, equals parentheses 2 minus x log of 3. So I'm going to show that in green. This is just used to be the exponent. Now it's being multiplied by the log. Alright, so when I do this, I want to get x by itself, but right now there's an x on each side and it's inside parentheses. So before I can get my x's together, I'm going to have to expand everything. Expand means to multiply it out all the way. So I need to take this log 4 and distribute it into the parentheses. The nice part about this is I don't really have to do much arithmetic. I'm just going to write 3x log 4 minus log 4. The not so nice part is it's going to make it really long, and it's going to look like I did a whole lot and be kind of scary looking, but I'm just taking the 3x times log of 4, and then I'm taking log of 4 times the negative 1, so minus log of 4. So I didn't really do anything hard, but now it's starting to become a really long equation. That equals, I have to do the same thing on the right-hand side. Take log of 3 and distribute it inside the parentheses. So I have 2 log of 3, and then minus x log of 3. So I expanded the whole thing, and now I'm going to look for my x's because I need to get my x's, same as solving a regular linear equation. You want your x's to one side and everything without an x in it to the other side. Well, there's an x here, and there's an x here. So I want to get my x's on the left. So this one, I want to move it over there to the left. This is minus x log of 3, so I'm going to say plus x log of 3. And I'm going to write it over here, plus x log of 3. Now I don't have to worry about adding these together or doing anything with them because they're not the same log. They're not like terms. I can't put them together. I'm just going to write them on the same side. And on this side I canceled it. And while I'm doing that, I want to go ahead and move my non-x pieces to the right. So here I have this one. I don't want it on the left because there's not an x in it. So I'm going to add log of 4 to the other side. And again, I'm not putting these together because they're not like terms. That's log of 3, this is log of 4. But I'm canceling that one. So I'm just going to rewrite the stuff I moved around. So I start here, I have 3x log 4 plus x log 3. And these canceled. That equals what I had already, 2 log 3. And then I moved the log 4 over there, so plus log 4. So I just switched sides. So now my x pieces are on the left, and my non-x pieces are on the right. So we're getting closer. We still are trying to get x by itself. All right, so for the next step, if I showed you 2x squared plus x, and I told you to get the GCF because there's an x in this piece and there's an x in this piece. You would bring an x out front and you'd have 2x plus 1, right? Everyone agrees with that? Not a big deal. We're going to do the same thing, but with a log. Okay? They both have a log, and then there's extra stuff that is not the x. Oh, I said that wrong. They both have an x, and then there's extra stuff that's not the x. We want to take the x out front, and then everything that's not the x, put it in parentheses. So the 3 log 4 plus log 3. So I factored out an x as a GCF. Equals the right side. We didn't change the right side at all. All right, we're getting very close to having x by itself, but it's x times this set of parentheses. If I want to get x by itself, if this is x times, I need to divide. I'm going to divide by, I'm not even going to write it all out. I'm just going to say divide by the set of parentheses. So it's a lot to rewrite. So I'm just dividing it by the set of parentheses on both sides. So on the left side, the parentheses are going to cancel. And then on the right side, over here, so I have just x. After I canceled the two sets of parentheses, it's just x. That's all that's left. Equals, the numerator, I didn't change that. I haven't changed that in a while. 2 log 3 plus log 4. And then the parentheses are these parentheses that I divided by. So 3 log 4 plus log 3. And that's the exact answer. If you want the approximate value, x is approximately 0.682. So here, I can group this in blue. So your assignment for 3-4 is on page 196, number 8, 19, 20, 24, 26, 37, and 47.